Hi everyone, today I'm going to show you guys how to analyze a stock correlations using Python. For this video, we're going to take an individual stock, compare the price movements, and plot to see the correlations. So before we start, what correlations metrics used for? Well, when we want to analyze a stock correlations, mean we want to see the relationships among the data, which are stock prices in this case. It makes us understand the market relationships of how different stock or sectors move in relations to each other. This is also the essential step if you want to do the feature engineering for stock predictions model. So let's start. I'm going to rename my file as the stock correlations. For the first step is we need to import the library. So in this case, we're going to import the libraries, including pandas, matplotlib, seaborn, and Yahoo Finance. So we click run. Next step is we need to import data. So I'm going to put the stock price in a variable called tickers. So since I'm from Thailand, I'm going to use a Thai stock from a CES50. I just randomly selected a 10 stock price in a different industry to see the correlations. And then we can select the start date. As simple like and end dates. Then I'm going to create a functions to download each of these individual stock. So download stock price. I'm going to add the parameters of stickers, start date, and end date. I'm going to create a dictionaries here to store the data. And I'm going to do a for loop for ticker in tickers. Tickers. Yahoo Finance.download tickers start end equal end date. And we're going to see the correlations only for the close price, so I'm going to download only for the close price. And then I'm going to return this. As a data frames. Run this. Alright, and then we're going to use these functions to download. So it's equal to stock price tickers start dates and end dates. Let's see. So if you found this problem of the rate limit error, you need to update the API. So I'm gonna do the pip install upgrade Yahoo Finance. Let's request paste. Restart sessions. So we're gonna run it all again. Alright, everything looks fine. So as you can see, date is index. So if you don't want this to happen, you can just use the data.reset index and in place 2. Wait. Then we got all the stock prices here. So next step is to normalize and visualize. So at first I'm gonna plot the data without using a normalizations method. So we're gonna do figured. We are using a fixed size of the 12%. And we're gonna do a for loop to plot so we're gonna do a for loop to plot the data, since start with the first index, because the 0 index would be date, so we'll start with the first index. Plot, and the x-axis would be a date columns, and y-axis would be the columns. All right, and label equal to columns. Then we're gonna plot using a pie plot, and then we're gonna plot using a matplotlib. X label is going to be dates. pt.y label is going to be the stock price, and plt.title would be stock prices, and plt.legend, plt.grade, this is not necessary, plt.ectix, then we're gonna plot it. Well, as you can see, the data here is quite in a different range. So this stock price is very high, and this stock price is very low, and we cannot see the patterns or the correlations between these data. So we're gonna normalize using a standard scaler. We're gonna import the scalar.preprocessing, import standard scaler. Then we're gonna normalize only for since the first indexed here, we're not gonna normalize a date, so it's gonna be columns to normalize equal data.columns. And we're gonna using a standard scaler, norm data equal scalar dot fit underscore transform data to columns to normalize. Then we're gonna change this normalized data into data frames. It's equal to norm data data frames. print this out. See, these data is already normalized. So we're gonna use this to plot it again, but this time change to this. Sorry, these need to be alright. Right now you can see that all these stock prices is already in the same range here, but it's very disaster. You can see the correlations or relationships here. So we're gonna do to see the correlations by plotting the heat map. We're gonna use the functions called. We're gonna use these functions to see the correlations of the data, and then we're gonna plot it. Figures fixed size. We're gonna plot a heat map using a seaborne sns.heatmap, and gonna pass the correlations matrix right here, and annotations true. Yeah, I misspell a word. Relations matrix, and a color map is cool warm. plt.title is the correlations of stock prices, and then plt.show. See, so this is a correlation heat map which visually represents the relationships between the different stocks based on their price movement, and the values range between 1 to -1. So the red color is a positive correlations, meaning that if one stock moves up, the other also moves up. And the blue is a negative correlations, meaning that if one stock moves up, the other moves down. So as you can see, this is a strong positive correlations, delta and the advance, meaning that if deltas move up, advance also move up. And in contrast, this is a negative correlations, meaning that if the LH goes up, deltas goes down. And that's all for this video. Thanks you guys for watching.